So, you power on your phone and within seconds, boom, you're connected. But have you ever stopped to wonder how that actually happens? How does your phone find one specific cell tower in a total sea of radio noise? Well, it all comes down to this incredibly clever process, kind of like a secret digital handshake.
I mean, really think about it for a second. Your phone boots up totally blind. It has no idea where it is, which networks are around, nothing. It's basically lost in a massive invisible city of signals. So what's the very first thing it does to get its bearings and make that first connection?
You know, the perfect analogy here is to think of your phone as a ship that's lost at sea in a thick fog. What it's desperately searching for is a lighthouse. It's looking for that one, single, powerful beacon that can cut through all the static and all the noise and basically shout, "Hey, I'm over here, connect to me."
Now, this lighthouse beacon, it's not just one signal. It's actually made of two very distinct parts. They're called the PSS, which stands for Primary Synchronization Signal, and the SSS, the Secondary Synchronization Signal. And these two signals are the absolute first things your phone hunts for.
Okay, so first up is the PSS. This is like the big, bright initial flash from the lighthouse. And its job is unbelievably simple. All it does is transmit one of three possible numbers, 0, 1, or 2. That's it, seriously. This little number tells the phone which sector of the cell tower it's hearing.
Right after the phone locks onto that PSS, it immediately looks for the SSS. This signal gives it the second piece of the puzzle, something called the cell group ID. This is a number that can be anywhere from 0 all the way up to 167. So now the phone's got two key numbers, a tiny one from the PSS and a bigger one from the SSS.
And you can see here, they're really designed for different jobs. The PSS is all about speed. It uses a special sequence that lets the phone get a quick, coarse lock, just to get me in the ballpark kind of sync. Then the SSS comes in right after to provide the fine synchronization, getting the timing absolutely perfect. So why these two numbers? What's the big deal? Well, when you combine them, they can create 504 unique combinations. And in the world of LTE, that's a magic number. That is the total number of unique physical cell IDs, or PCIs, that a phone can connect to. Think of it like a unique address for every cell in the world, and there are 504 of them.
So here is where the magic happens. This is the secret handshake. The phone takes that cell group ID it got from the SSS, multiplies it by 3, and then just adds the sector ID it got from the PSS. And boom! Just like that, it's calculated the cell's unique ID, a number between 0 and 503. The handshake is officially complete.
Okay. But knowing what to look for is only half the battle, right? Your phone still needs to know where in that vast ocean of radio waves to even start looking. And it turns out these signals have a very specific and frankly very clever hiding spot. Let's just put on our engineering hats for a second. Imagine it's your job to design this. You need every single phone, no matter who made it or how big the network is, to find this beacon signal as fast as humanly possible. Where would you put it? Well, you'd put it somewhere totally predictable, right? Somewhere every phone already knows to look first.
And the answer is just brilliant in its simplicity. The PSS and SSS are always broadcast in the exact same spot, right in the dead center of the frequency channel. They live in this tiny 1.08 MHz slice of spectrum, repeating themselves like clockwork every 5 milliseconds.
And this right here, this is the real genius of the whole system. It doesn't matter if the network is using a teeny tiny 1.4 MHz channel or a massive 20 MHz superhighway of data. The phone doesn't care. It doesn't have to scan the whole thing. It knows it can just tune directly to the center and that beacon will be there waiting for it. This one design trick makes the whole search process incredibly fast.
So let's put it all together. Let's walk through how this actually goes down. Now that the phone knows what the signals are and exactly where to find them, it can do this super efficient two-step process to officially lock on.
It all starts with step 1, the coarse search. The phone tunes to that center frequency and just listens for the PSS. As soon as it finds it, it gets its basic timing down, fixes any big frequency errors, and grabs that first number, the sector ID. Then it's on to step 2, the fine search. And because it already knows the basic timing from the PSS, finding the SSS right next door is a piece of cake. It locks onto that, gets the perfectly fine-tuned timing, and grabs the second number, the cell group ID.
So with those two simple steps finished, the phone has everything it needs. The secret handshake has been performed, and it's time for the payoff, officially getting on the network.
So let's just tie this all together one last time. You've got the PSS, giving you that sector ID for a quick slot-level sync. And right beside it, in time, you've got the SSS, giving you the cell group ID for a super precise frame-level sync. Two simple signals repeating constantly, always in the same place and working together perfectly.
And that's the whole journey. From being lost in a sea of static to finding that one clear, bright lighthouse beacon. By finding two simple signals and doing one tiny bit of math, the phone figures out exactly which cell it's talking to. It is now officially synchronized and on the network map.
But of course, just getting connected, that's only the beginning, isn't it? The phone's on the network, sure, but how good is that connection? Which leads us to the next big question. Now that the phone is all synced up, what's the very next signal it looks for to actually measure the strength of that connection? Well, we'll have to save that little secret for another time.